Hi guys, welcome to the Pepcoding. In this video, we are going to solve math chunks to make array sorted. So let's read the problem statement. Here, problem statement says we have given an array that is a permutation of 0 to array dot length minus 1. This means we have an array having a permutation, one permutation of the elements 0 to array dot length and minus 1. That means, and we need to split the array into some number of chunks. This means we need to split them in partitions. And now, if we individually sort them, if these partitions are individually sort, we will get a sorted array. And here one more thing is, we do not allow to shuffle the chunks. This is the main point of the question, that we do not allow to shuffle the chunks. And we need to return the maximum number of chunks to make the array sorted. That's the question. So now, for solving this question, I'm going to use chaining technique. Chaining technique. So let's see the technique. So here, let's say we have this array. That means we have the elements 1, 0, 2, 4, 3, and 5. Having index 0, 1, 2, 3, 4, and 5. Now here, if we see this, we know that all the elements are the indexes of the array. If we want to sort them, we need to find the range of all the elements till that index to sort. Now let's say if we are at 1. We are at 1. Here the range from 1 is till that index 1. So 1 will be go till 1. Here if we are at 0, this means 0 cannot go to the right. Here all the elements are greater than 0. Till the elements are smaller, we can check the range of all the elements. Here 1 is till 1 because 0 is smaller than 1, but here 2 is greater than 1. So the range of 1 is only till the 1 index 1 and 0 also have the range of index 1. Now here if we are at 2, it can go till 2 because the next value is greater than 2. Now we are at 4. 4 in the next value is 3. 4 can go to 3, and if 4 tries to go to 5, here 5 is greater than 4, so the range of 4 is only at this point. And for 3 the range is only here. Now if we are at 5, the range is only at 5 because after that the elements are all elements are used. Now here if we see that, if we do the partition like this, 1, 2, 3, now we will get the first chunk, second, third, and fourth. This means we have the number of chunks that are equal to 4 for this array. Now here if we sort them, individually sort them, here if we sort them, this will be 0, 1. If we sort this chunk, it will be 2. If we sort this chunk 3 and 4. If we sort this, we will get 5. So here we can see the result is in sorted. This means maximum 4 chunks can be done to split them in 4 parts to get the maximum chunks of the sorted array. Maximum chunk to make the array sorted. Now let's take another example. Let's take another example. 3, 0, 1, 2, 5, 4. Having indexes 0, 1, 2, 3, 4 and 5. Now see the range of 3. 3 is greater than 0, it will go. 3 is greater than 1, it will go till 1. 3 is greater than 2, it will go here. 3 is smaller than 5. This means the range of 3 is till here. Now if we are at 0, the range of 0 will be only at that position. Now we are at 1. The position of 1 is at 2, at index 2, and it can go till that position only. Now we are at 2. 2 have also the position till 3. It can also go till 3. This means the range of 3 can go till 3. 0 having the range till 0, 1 till 1, and 2 having range till that position. This means here we can get a chunk. Now we are at 5. 5 is greater than 4, it can go till 4. And here 5 is also, if we go till 4, 5 is also equal to the index. Here 3 can go till 3 index. Now we are at 4. 4 having range till 4. So this means for this example we have only 1 and 2. That means 2 maximum chunks we have for this array. If we sort them, we will get 0, 1, 2, 3 and then 4 and 5. This means we have the sorted array having chunk 1, chunk 2. So this is the explanation of the solution. Now let's take one more example for understanding the code. So we have 3, 0, 1, 2, 5, 4, 7, 6 and 8, or I can say let's take 8, 6 and 7. Okay, or 8, 6, 7. Okay, 8, 6, 7. So here indexes are 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now start. The maximum value is starting from 3. Here the range of 3 is at here, the maximum is 3. At 0 the maximum is 3. At 1 3 is maximum. At 2 3 is also maximum. And now the maximum is 5 at 5. And here we can see the range of 3 is from this to, from 0 to 3 index. And here we can increase the count for the chunks. Start from 0. We will increase the count here by 1. This means this 3 having range till 3, 0 having that point range, 1 is at the position 2, 2 at the position 3. These elements cannot go to the after the 3 index, after the third index. So this means this can be a partition, this can be a chunk. So we are increasing the chunk. Now maximum is 5. Here at 4 maximum is 5. Now after that maximum is 8. And the range of 4 is till 5 index and range of 5 is till 5 index. This means we can increase the number of count of the chunks by 1. That means now the chunks are 2. Now here 8 is maximum. At 6 8 is the maximum. At 7 8 is the maximum. And after that carry out of bound. This means at 8 from 8 till the index 8. We have the third chunk, so we will increase the number of count, that is 3. So here we can get the maximum chunk of the array, that is 3. Now if we sort them individually, this will give 0, 1, 2, 3. This part will give 4, 5, and this part will give 6, 7, and 8. So this is the sorted array, and we will increase the number of count. When we will increase the number of count, when the maximum, here we can see when we are at when the maximum was 3 and the index was 3, this means we have one max chunk. When the maximum was 5 and the index is also 5, here we can see index and maximum is 5, we are increasing the number of count by 1. And here when the maximum is 8 and index was 8, the number of chunks increased by 1. This means if maximum is equal to the index, this means we have the number of chunks increased by 1. So count plus plus. So let's code this. Now what we need is a maximum value and a count for the chunks. Now we will start our iteration from 0 till array dot size. We are iterating all the elements of the array. Now each time we will find the maximum. So here in CPP there is a max function, so I am going to change the variable name. Now maximum comma array at I. This will give the maximum till all the indexes. Now the condition for counting the chunks, when the maximum is equal to I, this means we have the number of counts increased by 1. And at the end we need to return the count. So this is the simple question. Now let's run this. Now let's submit this. So all the test cases are also passed. This was very easy question. What we need is to find how we will solve the question. What is the what the question says and what we need to do. And for doing the solution, we just need a maximum for the count, maximum and the count, as we have seen in the explanation. And this was a very good question. See you in the next video. Thank you.